That's how quantum gets speed. Now let me talk about speed. Whether in quantum computing or sensing or communication, wherever I'm talking about, quantum gets enormous amount of speed. Let me explain you this concept. In classical world, you can look at my hands so that you can understand better. Imagine a maze. Okay, we have a maze. So what is the problem statement of the maze? If there's a maze like this, so there's an entry from here. So we need to figure out how to get out. So the goal is to come out. So in the classical world, any computing, when you give a problem statement or a computation, first it goes in like this. There's a block, comes back, it tries here, it goes in like this, block, comes back, and if there's something, so every time it hits a roadblock, it takes, comes, but eventually the computing will happen and the result will be given. But this is how it travels, the maze. In quantum world, there is a concept called entanglement. Okay. This also I will explain you in a very plain English. Entanglement means the same thing can exist in two places, but completely integrated with each other. It's only one, but can exist in two places, which means what happens, the same example of a maze, there's a maze. So we have two ways, one way this way, one way this way, okay, to go. So in the classical world, it'll go here, hit a road back, come back, and goes here. In quantum world, right here, it splits into two. One goes this side, one goes here. Here there's a block that's gone. This continues to go. And here again, it splits into two. So quantum has this concept. It has a concept of entanglement where in plain English, it could split into two, same one, completely integrated with each other, which means whatever is happening here, it's happening here too, but still exist in two different places and perform two different tasks. That's how quantum gets speed. Entanglement